In this video, I'm going to talk about the quadratic parent function, which is y equals x squared. And we're going to just plug in some numbers here to make a table and plot some points so we can get an idea of what a quadratic function looks like. So if I plug -2 into x squared, well, -2 squared is just -2 times -2. Well, if I take -2 times -2, I get +4. If I plug -1 in, -1 times -1 gives me +1, 0 times 0 gives me 0, 1 times 1 gives me 1, and 2 times 2 gives me 4. So if I go ahead and plot these points, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4, okay, we'll get a graph that looks like this. Okay, it looks kind of like a U-shaped graph. And we call this U-shaped graph of a quadratic, we call it a parabola. Okay, so a quadratic equation gives us a parabola graph that's U-shaped. And then we have two terms that I want to talk about when I talk about a parabola. And the first one is this point at the base of the parabola, or like in the middle of it, right, where it switches from going down to going up. That point's called the vertex of the parabola. Okay, so it's the vertex. I'll write it over here in the white so you can see it a little bit better. But we call that point the vertex. And then you'll notice that the U is symmetrical, right? Like if I were to draw a line, if I were to cut this in half, right, it mirrors itself, right? It can mirror itself. So this line, okay, that I've drawn in a dash here that goes down the middle, we call that line the axis of symmetry. Okay, so those two things, axis of symmetry is the line in which the thing is symmetrical. Okay, it mirrors over that line. And then the vertex is just this point at the bottom of the parabola there. That's sort of the middle of it. Now, some other things I want you to notice about this graph before moving on to some examples is what the vertical stretches are. So if you look, if I start at the vertex, when I go 1 unit over from the vertex, you'll notice that the height here, the stretch, is a 1, right? When I go over 1, it goes up 1. When I go over 2, you'll notice that this stretch is 4. Okay, so the first stretch, when I go over 1, I get a height of 1. When I go over 2, I get a height of 4. The reason why that's happening is because we're dealing with a quadratic. We're squaring the numbers. So when you go over 1, well, 1 squared is 1, so I have a height of 1. But when I go over 2, 2 squared is 4, so I get a height of 4. If I were to go over 3, well, 3 squared would go up 9. So my next point would actually hit up here at 9, okay? So the heights, the stretches that we're getting, are just how many we've gone over from the vertex squared. All right, let's look at some examples of graphing these. Now, just like our absolute value functions, quadratics are going to work the same way. So in example 1 here, I have y equals x minus 3 squared minus 4. Well, just like the transformations with absolute values, this -3 is going to move me right 3, and the -4 is going to move me down 4. Okay, so this vertex point, okay, that was at the origin, is now going to move right 3 and down 4. So on this graph, I'm going to go right 3, down 4, and that is going to be where my vertex is on the graph. Okay, so I'm going to put a little V by it for vertex. Then I want to find my other 4 points, okay? So I want to find these two and then those two. So starting from my vertex, I now use the A value, and I notice the A value is a 1 here. Okay, so because it's a 1, I'm taking all my Y values that I originally would have, and I'm just timesing them by 1s. Well, if I times them by 1, the numbers don't change, right? 4 times 1 still 4, 1 times 1 still 1, 0 times 1 still 0, 1 times 1's 1, 4 times 1's 4. Okay, so none of these numbers change. They stay the same. So what that means then is on my graph, when I go over 1, I'm just going to go up 1. When I go over 1, I go up 1. When I go over 2, I'm going to go up 4. And when I go over 2 the other way, I'm going to go up 4. Okay, so I get a parabola that's been shifted right 3 down 4, but the stretch has stayed the same as the original. Okay, it was going up 1 and up 4. You'll notice here I have a stretch of 1, and then when I go over 2, I have a stretch of 4. So my stretch, because it's a 1, has stayed the same. Now, to fill in these two pieces of information, the vertex and the axis of symmetry, once again, the vertex is just the point here at the base of the parabola that's kind of in the middle of the two lines. So if we look, that vertex is at 3 on the x-axis and -4 on the y, so that is the point 3, -4. And then the axis of symmetry is the line that cuts the parabola in half. Okay, it's the line where it's symmetrical, and that's cutting through x equals 3. So we would write x equals 3 as our axis of symmetry. And just as a side note, the axis of symmetry, because it cuts through the vertex, will always be the same number as whatever your x coordinate is of your vertex. All right, let's look at one final example here. So looking at example 2, I have y equals 2 times x plus 3 squared minus 1. And once again, these are really just doing what the transformations were for absolute values. It's the same for quadratics. So plus 3 is going to take me left 3, and then -1 is going to take me down 1. So from the origin, I know I go left 3, down 1. That's where the vertex is going to be. Okay? The vertex is going to be at that spot. Now, this problem is a little bit trickier, and the reason why is because you'll notice my stretch here is now a 2. Okay? What that does then, this 2, because it's being multiplied, it's going to multiply all my original y values, all my original stretches by 2. So instead of multiplying by 1s, I'm now going to multiply them all by 2s. So 4 times 2, well, that gives me 8. 1 times 2 gives me 2. 0 times 2 gives me 0. 1 times 2 gives me 2. 4 times 2 gives me 8. So from my vertex now, when I go over 1, okay, I now go up 2. So over 1, up 2, over 1, up 2. And when I go over 2, okay, so when I go over 2 here, instead of going up 4, I'm now going to go up 8. So on my graph, I go over 2, up 8. And then the other way, I go over 2 and up 8. Okay. And it's usually the trickiest part is finding these last 2 points for students. So I'm going to do a little bit more explaining on how I find those. Okay. So when I'm finding these 4 other points, okay, I'm using the A. Notice that when I go over 1, whatever the A value is how much I go up, right? When I go over 1, I go up 2. When I go over 2, normally, right? Normally, if we look back at the parent function, normally when I went over 2, I only went up 4, right? But because I'm multiplying by 2, this vertical stretch here of 4 has doubled, okay? It's no longer 4, it's now twice as much. So now it has to go up 8. Okay, so you'll notice when I go over 2 from the vertex, and now I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my vertical stretch here is now an 8 when I go over 2. Okay, it's taken these stretches and it's doubled both of them. Okay, now lastly, once again, we want to label our vertex and our axis of symmetry. So my vertex is at -3, -1. And then remember the axis of symmetry is just that line that cuts the parabola in half. And it's going to be -3 on the x. Okay, so it's x equals -3. And the reason for that is because this line is running through -3 on my x-axis. And remember, it's always going to be the same value as your x coordinate of your vertex because it runs through the vertex.